So what we need to look at on this one is we're looking at a triangular shaped ramp. So this is 1-5 from your homework. We're going to begin with question 6. So anytime we have a triangle, we're going to have to use the Pythagorean theorem eventually. And we need to see how all of this relates to make our triangle for the sides. So it says, a building needs a ramp to make it handicap accessible. By law, the ramp must run 10 inches horizontally for every 1 inch of rise. If the surface of the ramp is 52 inches, how far above the ground is the inclined end of the ramp? And we want to round to the nearest tenth of an inch. So let's try to draw our picture. So here's our ramp. Now, what do we know about the ramp? We know that the ramp has a surface of 52. So that's going to go here, and that's our diagonal, right? Now, what do we know about the ratio of the rise to the run? Well, it says, by law, the ramp must run 10 inches horizontally for every 1 inch of rise. So it's a 10-to-1 ratio. Now, do we know what the height here is? No. So that's going to be our unknown. That's going to be the variable x. How does the height here relate to the run? Well, it's a 10-to-1 ratio, and if this one's an x, this one's going to be what? 10x, right? Do you see how it works out now? Because it's a 10-to-1 ratio. Now we can apply our Pythagorean theorem. What we need to make sure of is that our diagonal is the C. The others don't matter. Which one is which? So one is A, one is B. The important part is to make sure that the diagonal is your C. Now we know that A squared plus B squared equals C squared. That's our formula. And we're going to now apply our formula. So we're going to plug things in. So we've got x squared, and then b is going to be a 10x quantity squared, like this, and then it equals 52 squared. Okay, so we're just looking at questions from last time. This is question number 6. And so what we're doing is we're looking at a ramp, so we're going to make a triangle. It's a 10-to-1 ratio. That's why this one is 10. This one is x, this one is 10x. Because it's a 10-to-1 ratio. We know the length of that ramp is 52. Then we apply our Pythagorean theorem. I'm going to do one more step for you. A lot of times students make a mistake here. Now, notice I put the parentheses around that 10x. Because you've got a square. So you have to distribute that square through each part. So when I do that, I now have x squared, and 10 squared is 100x squared. And 52 squared is, I've got a calculator here, okay, 52 squared is that 2704. I'm going to add those together, and that gives you 101 x squared equals 2704. And I think you could finish it from here. How would you finish it? I'm not going to finish it, but how would you finish it? Yep, you would divide by that 101 first, right? And then you would apply your square root property. Now, do we need to worry about the negative answer at all? No, because our answer has to be what in this case? Positive. And how far do we have to round here? It says, if we read it, it says round to the nearest tenth of an inch. So when you get your answer, it's not going to be a perfect square, and all you have to do is round it to one place, nearest tenth. So that's all you're going to need to do. X is going to be your answer because we're looking at how far above the ground it is. But the key takeaways here are the fact that it's a 10-to-1 ratio and that we're going to be using our square root property. So you divide by that 101 and then take your square root. Is everyone okay with how I set that one up? That was question number 6. We also asked about question number 9. So let's look at question number 9 here. So question number 9. On question number 9, we're going to be plugging information into a formula. So let's look at question number 9 here. So question number 9. What we need to focus on is our formula. Right? And there's 3 variables in here. We know 2 of them. We're going to have to find the R. So we're looking at compound interest. So if an amount of money, called the principal P, is deposited into an account that earns interest R, compounded annually, then in 2 years, that investment will grow to an amount A, given by this formula. The principal is going to be $5,500, and it needs to grow to $6,415.20. What we need to do is figure out what the pieces are and put them in the formula. So let's write up our formula. And our formula, in this case, is A equals P times 1 plus R squared. And we need to make sure that we understand what the A and what the P are. So A is the ending amount. And P is going to be the principal or the starting amount. And we'll fill those in a moment. So we end up with that $6,415.20. So that goes over here. What did we start with? We started with $5,500. And now we can finish. I'm going to do one more step for you. And while you're writing this down and copying it down, what property do you think I'm going to be using? I'm not going to use zero factor. I'm not going to FOIL it because I can make it easier. I can use the square root property. Okay, that's going to be your absolute easiest way to solve it. You could FOIL all of this out, but you would end up with an extra page of work. So the easiest way is to use the square root property. So let me go ahead and help you with that. So I'll do one more step. So I would go ahead and divide by the 5,500. And then I'm going to rewrite this as 1 plus R, quantity squared, equals now, when I divide, so I'm going to go ahead and divide those out, just so you can see here, 6415.2. I'm going to divide that by the 5,500. And that gives you the 1.1664. Okay. And then how do we get rid of a square? Square root. I'm not going to finish it, but what would you do? Square to both sides, add on your plus or minus. One of these is going to work, one of them is not. You cannot have a negative interest rate, so the one that's negative is not going to work. But you can finish it from here. So take the square root, add your plus or minus, and then you should be able to solve it for R, and then rewrite R as a percentage. Is everyone okay with that? Any others out of 1.5 to look at? Do we have any other questions out of 1.5? Uh-huh. Yeah, I can go ahead and finish it. Okay. Just to clear up any confusion, let's go ahead and finish this. Okay, if I was going to finish this for you, how would I get rid of a square? Square root. Okay, so that's going to add in now plus or minus there, won't it? what happens on the left-hand side? Remember, we looked at this in 1-4. The square and the square root, those cancel out. And that leaves you with an r plus 1. Right? Or 1 plus r, same thing. On the other side, we still have our plus or minus. And what's the square root of that 1.664? Well, it actually comes out to be 108. Or sorry, 1.08, right? And then, what are our two equations? R plus 1 equals 1.108. And R minus 1 equals 1.08. Now we can solve it. I'll go ahead and finish it just so we understand why one of these is the correct solution and why the other one is not. So if I move this 1 over, that gives you R equals now, by moving it over, 0. That should be a plus there. I made a mistake with the sign. My mistake. So that one should be negative there. So I move that over. So that's going to give you 0.08. That one can work. What about the other one? When I move that 1 over again, that gives you R equals a minus 2.08. Right? Now, why does that minus 2.08, why does that not work? Can you have a negative interest rate? No. What would my interest rate now be as a percent? As a percent, 0.08, well, that is 8%. So what would your answer on this one be? 8%. So we took our square root, right? We moved that 1 over, and that gave us 8% over here. This one was negative, so it doesn't work at all. Does that clear up that? So the only answer that you'll have on that one is 8%. Okay, any others to look at out of 1-5? Sure, which one? Question 8? Sure. Okay, question 8. What we're doing on question 8 is we're plugging values in to a formula. So question 8, and I'll leave this up so you can copy that down too. But question 8, we're looking at throwing a ball downward from a building. You're given this equation. S equals 16t squared plus 32. And S is going to be how far it goes down. Now, what do we want? We want to know how long it is going to take this ball to drop 133 feet. So what is my S going to be in this case? 133. So we're going to plug in that 133. This one is probably not going to factor. I can safely say that it's not going to factor because it says to the nearest tenth. So that tells me that it's probably not going to factor. I'll do one more step. So this needs to be set to 0. And let's see, does 16 go into that 133? No, it does not, does it? 133 divided by 16. No, it is not. Nothing else is going to factor out. Okay, so this is not going to go any further. This is not going to factor out nicely, so you're going to have to use the quadratic formula. Okay, so you're going to solve it using the quadratic formula. So we moved everything over. It's been set to 0. Solve it with the quadratic formula. Can time be negative? No. So one of these solutions is not going to work. So you'll cancel out the negative solution there. let's go ahead now and begin 1.6. And 1.6, there are a lot of parts to 1.6. And it's kind of a complicated section. We're going to learn how to solve a variety of different types of equations. So several different types. And I think we'll start with the square roots. So we're going to learn how to solve square root equations first. Okay, so we're going to learn how to solve equations that have square roots. And if it has a square root, step number 1 is you want to isolate the square root. Now, a moment ago, we got rid of a square. And how did we get rid of a square? We use the square root. So now we've got a square root. So what's the opposite of a square root? Square. Okay? So then you're going to square both sides. That's going to get rid of your square root. And then you solve the resulting equation. And then finally, you have to check all solutions in the original. So you're going to have to actually plug in the values that you get back in the original problem and check to see if they work. In most cases, you're going to get 2 solutions, and only one of them is going to work. But you've got to check both of them and see. Now, I only gave you 2 questions that have these square roots. I'm going to pick one of them from our textbook to look at. It's going to be like your homework. Okay, so let's look at one of these. What you're going to have to do is isolate your square root, square both sides to get rid of it, and then check your final answers. So let me pick one of these from our textbook here to look at. Okay, right page here. So we're going to look at one of these. Again, we follow our step-by-step procedure. Each type of equation has its own procedure that we need to use and follow. We're going to look now at question 45. And this is on page 165. Okay, so this is what we're looking at here. We've got x minus the square root of 2x plus 3 equals 0. So this is what we've got. Now, these are really not that difficult to solve. But we need to follow our step-by-step procedure. So the step-by-step procedure, step number 1 is what do we need to do? We need to isolate that square root. So what does that mean? That means we get it by itself, and I'm going to move it to the right-hand side. So I'm going to move this square root over by adding. So that now leaves you with this. So I moved it over, right? I added it to both sides, and I got to this point. Now, we don't have a square, we have a square root. And what's the opposite of a square root? Square. So we think in terms of opposites. Addition cancels out subtraction. Multiplication, division's its opposite. Square root's its opposite. So we need to get rid of the square root, so we're going to square both sides. Now, when we square both sides, the left-hand side, well, it comes out as an x squared. And the right-hand side, well, the square and the square root, they're opposite, so they cancel. So that simply leaves you with a 2x plus 3. Okay. Now we've got an equation that we can solve. So now we move it over, set it all to 0, and we solve it. So now we've got x squared minus 2x minus 3 equals 0. And we can easily factor this. First times the last is a negative 3. And so what do I know about my signs? Are they the same or are they different here? They're going to be different. And can you tell me what two numbers are going to work? Yep. We need a negative 3, right, because the sign in the middle, and a positive 1. So that gives me then x minus 3, x plus 1 equals 0. So x minus 3 equals 0, so x equals 3. X plus 1 equals 0, so x equals a negative 1. Now, we are not done yet, because our step-by-step procedure says we isolate, we square, we solve. The last step is we have to check these back in the original. So we're going to have to take each one of these and we're going to have to plug the value back into the original. So we're going to check each one of these in the original. And our original was this. X minus the square root of 2x plus 3 equals 0. That is our original. And we're going to check first off x equals 3 here. And we need to see if it comes out to be the same on each side. And I think it will, because 2 times 3, that's a 6. 6 plus 3 more makes it a 9. And what do we know about the square root of 9? 3, and we've got 3 minus 3. Does that equal 0? Yes, it does. So this works. Now, chances are that one of these will work and the other one will not work. You have to check them, and do not just think the negative won't work. You have to check them both. You can't just assume that the signs make a difference. So now we need to check the other one. So the other one that we found was x equals negative 1. And we're going to plug it in. So that's going to get plugged in here. Okay, now be careful with your signs. This one is not going to work. 2 times a negative 1, well, that's a negative 2, right? Plus 3 makes it a 1. Why is this one not going to work? Well, the square root of 1 is 1, but when you put these together, what do you get? Negative 2, and does negative 2 equal 0? No. So, negative 1 is not a solution. So what is the only answer that we have here? 3. So that is the answer. So that is the only answer that we have. The other one didn't work. Now, in some cases, you might get 2 solutions and neither one of them work. Or they might both work. But you're going to have to plug it back in, and you're going to have to check each one and see if they work or not. And these go along with the 2 questions from your homework, and they look like questions 10 and 11. So these are going to be like 10 and 11. from the homework. Do what now? Yeah, for our answer, our answer would just be x equals 3. Because this one doesn't work. So when I write my answer, all I would want to see is just this x equals 3. Okay? When you look at these, they're going to be done the same way. So when we look at 10 and 11, they're already set up, so all you have to do is square both sides. Both of these you're going to have to square, set them to 0, and solve. And then check your solutions. So that's how you solve questions that involve a square root. Isolate the square root, square both sides, solve it, and then check your solutions. Another type of equation that you're going to encounter is one that has rational exponents. Now, when we solve rational exponents, we're going to simply clear the fractions. So I'm going to give you a couple of these to look at. We'll do at least one. If we have time, we might do two, because they're not difficult at all to really work through. So let's look at one of them here. How about question 85? And this is on page 166. Question 85. Rational exponents, well, these are just fractions. So they're going to be fractional powers. So question 85 is x to the 2/3 power equals 2 x to the 1/3 power. So these are fractions. They have fractional powers. So when we say rational, that means fractions. How do we get rid of the fractions? We're going to clear them just like we would clear any other fraction. When I look at my fractions here, what do we have for the denominators? 3's. So we're going to have to cube both sides. It's a power, so we have to take it to the 3rd power on both sides. Okay, that's going to clear out my fractions there. Now, when I distribute through, we've got to make sure that we cube everything. Not just the exponent here. The 2 has to be cubed as well. So these are going to be fractions. Rational means fractions. Okay, and these are fractional exponents. When I cube, what happens here? Well, that 3 and that 3, that cancels, so that leaves you with an x squared, doesn't it? Is everyone okay with that? Okay, those cancel. What about the right-hand side? Yep, and where did that come from? Well, we need to work with the 2 first. And it's not 2 times 3, it's 2 cubed. So it's 2 cubed, and 2 cubed is 8. So that's going to be an 8 there. And what happened with the 3's on our fractions? They cancel out, and that leaves you with an x there. So does everyone see how I got rid of my fractions? And these are pretty simple to solve. But make sure that you distribute that power through each part. The numbers included. And they're not multiplying. It's not 2 times 3. It's 2 cubed. That's the important takeaway there. Now, how would you solve this? If I gave you this to solve, what would you do? Can someone tell me? I can't use the square root property. Why not? Okay, to use the square root property, you have it needs to be x squared by itself. We can't have this extra x. So we can't apply the square root property because we've got an x squared and we've got an x. But what we can do is zero factor. So we're going to move that 8x over. And that leaves you with that. How can we solve this? What can you factor out of here now? Yep, someone said it. We can factor an x out. And that's going to leave me with now x minus 8. Is everyone okay with that so far? Now, what are my two solutions going to be? One of them is x equals 0. What's the other one going to be? Yep, x minus 8 equals 0, and x equals 8. And you do not need to check these. You only have to check the square roots. So these are not square roots, so we do not have to check them. And this looks like question 12 from the homework. Sure.
So when it's x squared equals to 8x, and we just divide by x, then we get that x equals to 8.
You'll get the x equals 8, but you got to remember that you actually have 2. Okay, and I don't like to have you divide by x up here because you'll lose the solution. Because if you divide by the x, see, that would give you x equals 8, right? But you wouldn't remember that. So that's why I always like to have you write it out and factor it. That way you see you get both solutions. I never want to have you divide by x because you'll lose one. If that makes sense. So set it to 0, factor out your x. Don't divide by x because you'll lose a solution. And then you get the 2 of them. And question 12 is almost identical. It's basically the same, just instead of a 2, it's got a 3. So it's very, very similar. Another type of equation that we're going to look at is equations that have multiple solutions. And these are going to require us to factor. And the highest power tells us how many solutions we have at most. So these are going to involve factoring again, but we're going to get multiple solutions, more than just 2. In this case, we're actually going to get 4 on these. So we're going to look at question number 89. And this is on page 166 again. So page 166, we're going to look at question 89. So this is what we've got here. It looks similar to what we have worked with before. But it's normally a square here. And this 4, that tells me how many answers I'm going to have at most. So I can have at most 4 solutions. So I'm going to have at most 4 solutions. The way we're going to solve this is we're going to factor it just like we would factor any trinomial we've done before. Okay, it's set to 0. I've got my 3 terms. There's no number. We put a 1 here. And 1 times the negative 15. 1 times negative 15 is a negative 15. And what 2 numbers multiply together to give you that 15, subtract from each other to give you that 2. Yep. And sign in the middle is positive, so we need a positive 5, and we need a negative 3, don't we? Here's where it's different. Here's the new part. When we factor it, normally it would be an x and an x here, but this is x to the 4th. So I split it up into x squared now and x squared. And then we have our numbers. We have a 5 and we have a minus 3. So I factored it the same way we would factor all the others. Nothing new. Only difference is, instead of it being just an x and an x, I split this up and I got an x squared and an x squared. Now, when we solve this, each one of these is going to get 2 solutions because we're going to use the square root property, and that's going to give us plus or minus. So let's go ahead now and get our 4 solutions total. So the first one is x squared plus 5 equals 0. So that gives me x squared equals negative 5 when I move it over. And we need to get rid of a square. So the opposite of a square is a square root. And whenever we take a square root, what do we add in? Plus or minus. That leaves me then with x equals plus or minus, the I comes out because that's negative, square root of 5. And so I actually have 2 solutions from here. I have x equals I square root of 5, and I've got x equals a minus I square root of 5. So is everyone okay with that so far? 2 solutions from there. What about the other one? X squared minus 3 equals 0. So x squared equals 3 when I move it over, right? And again, how do we get rid of a square? Square root. And do not forget that plus or minus. And that leaves me now with x equaling plus or minus the square root of 3. And so what are my other 2 solutions? Yep, x equals square root of 3, and x equals a negative square root of 3. And that's how you get the 4 solutions total. Is everyone okay with how I got the 4 solutions there? So you factor it like you always would. Any others? Okay, break it down. How do you get rid of a square? Square root. So you break it down, take the square root of both sides for each part, and you end up with your 4 solutions total. And this question goes along with questions 13 and 14. So that's going to be like questions 13 and 14. Huh? Okay, why do I have an I? Well, remember back in 1-3, whenever I take the square root of a negative number, what does that give you? It gives you imaginary, right? So this one had the square root of a negative 5, so because it was a negative 5 underneath the radical, I bring out an I. This one is a positive 3, so there's no imaginary part at all with it. So this one's real, and this one's pure imaginary over here. So do you see the difference now? Yep. And if you ever have questions, be sure to stop me and ask, because I can explain things, and we can talk about it. So this one's imaginary because of the negative underneath that radical. And it brings out an I. So I put the I in front as your square root, and I've got 2 solutions because of the plus or minus. Same thing over here. This one, though, is real because it's a positive 3. 3 doesn't break down, so that gives you the square root of 3, and also minus the square root of 3. Now we've got one more type of equation to solve. These are the ones that probably take the longest to go through. And these are going to be our rational equations, so the fractions. Again, rational means fractions. Now, the first ones that we're going to talk about for 1 and 2 is we're going to be talking about the domain and what the domain is and how we find out what numbers are not in the domain. So the domain is the possible values of x. And what we do not want is division by 0. So no division by 0. Because we cannot take a number and divide it by 0, right? That's undefined. So when we look at these, the first ones, questions 1 and 2, we're not solving. All we're going to be doing is find out what values cannot possibly be solutions. What values are not in the domain. So that's going to be our directions. So we're going to find the values not in the domain. Not solutions. So these are the ones that are not going to be solutions. We're not going to be solving these. We're only going to be looking at the values that will not work. Okay, so we are not going to be solving these. All we are going to be doing is looking for what values give me division by 0. Okay, so the domain, that's your definition, is the possible values of x. So what values are legitimate solutions? What we're going to be doing is we're going to be finding the values not in the domain, the ones that are not possibly a solution. And that means no division by 0. So what we're going to do is we're going to set each denominator to 0. And we're going to solve. So x minus 5 equals 0. What number will not work? 5. Because when I solve it, I get 5. But why does 5 not work? Because if I plug 5 back up in here, see, then down below I get 5 minus 5, which is 0. And can you take 8 and divide it by 0? No. Why we are doing this is we're going to be solving these in a moment. But we need to make sure that our answers are legitimate answers at the end. So we're trying to see what numbers will not work. So if we get those, we can take them out. What about the other one? And there's going to be 2 solutions that aren't in the domain. One from that. What about the other one? 4x minus 5 equals 0. Okay, so we'll move that 5 over. So 4x equals 5. Divide by your 4. So what's the other value that will not work? 5/4. Because that would also give you division by 0 here. So what 2 values will not work? 5 and what? 5/4. So those will not work. Let's try another one. Again, same directions. Find the values not in the domain, not solutions. They're not going to be solutions. so this is what I'm going to give you this time. We are not solving these. All right? So we are not trying to solve these out. The first two questions in your homework, you find the values that do not work. The later questions you solve. So that's why I made them multiple choice, so that you wouldn't make a mistake and try to solve it. We are not solving this. We are finding the values that will not work. So what do? We set each denominator equal to 0. And we're actually going to get, in this case, 4 numbers that are not going to work. So let's find those 4 numbers that do not work. So we set each denominator to 0. Here's our denominators. I do not care at all about the numerators. So it does not matter what the numerator is. That's irrelevant. All I worry about is my denominator. So what do we have? We have 2x equals 0. So divide by your 2. 0 absorbs it. So x equals 0 is one number that will not work. What's another one? Okay, x minus 5 equals 0. So moving it over, x equals 5. Also does not work. And what about our last one? Let's try to factor this one out. We've got x squared plus 6x plus 7. Oh, wait, I wrote it wrong. Just make that 7 and 6 here. Flip them around. Sorry about that. That way it'll factor. My mistake. Make sure you flip them around. Sorry about that. Make that a 7 here in the middle, 6 on the edge. That way it'll factor. Sorry about that. That was my mistake. I just wasn't careful when I flipped them around. This will factor because first times the last is a what? 6. What 2 numbers give me 7? 6 and 1. Yep. And that factors then into, and that's equal to 0. That factors into x plus 6. Okay, x plus 1 equals 0. And so x plus 6 equals 0. So x equals negative 6. X plus 1 equals 0. So x equals a negative 1. And those are the numbers that are not in the domain. Not possible answers. And so this is going to be like questions 1 and 2 from the homework. So like questions 1 and 2 from the homework, that's what you're going to be doing on those. I made these multiple choice to make them easier. That way you don't get confused and try to solve them. That's why I made them like that, so you wouldn't actually try to solve them, because you got to read the directions, and it says decide what values of the variable, that means x, cannot possibly be solutions to the equation. So you need to look at it, see which numbers will not work, and it's going to be one of those 4 choices. Now we're going to come to the questions that take more time to solve. And now we're going to be solving rational equations. And when we go to solve rational equations, we've got to make sure that we follow this step-by-step procedure. So that's the next thing we're going to look at is rational equations. And we're going to be solving these now. And we have a step-by-step procedure. So when we go to solve these rational equations, the first step is you find the numbers that are not in the domain. Step number 2 is you clear the fractions. Step number 3 is you solve. And step number 4 is you check the possible solutions with step 1. Okay, so it's a step-by-step procedure. So the first part is what we just did a moment ago, where we find the values that will not work, and we make sure that we know what they are. Then we clear our fractions. Then we solve the resulting equation, which may require you to factor, it might be linear, and then whatever solutions you get, you check them back with step number 1 to see if they're a legitimate solution or not. Again, these take a little bit of time to go through. You may have to factor several times on these. But I'm going to look at several of these out of our textbook. We're going to start off with some easier ones. And then we'll look at some harder ones. Let's start with question number 22. And this is on page 164. Question 22. So 3 over x minus 2 plus 1 over x plus 2. And that equals now 12 over x squared minus 4. So let's go ahead and go through our procedure. Now, first thing I'm going to do is I'm going to factor, because if you need to, factor first. What do we know about x squared minus 4? How would you factor down x squared minus 4? Does anyone remember? Yep, this is a difference of squares, right? Because 4 is a perfect square of what? 2. So how would this factor? This would factor into x plus 2, x minus 2. So let's rewrite this so that everything is factored. So I'm going to rewrite it, factored. Now, what numbers are not in the domain? What numbers are not going to work? Does anyone know? Right, 2 and negative 2. Why are 2 and negative 2 not going to work? Because here, 2 is not going to work, and a lot of times you can look at it and tell. If I plug 2 in here, 2 minus 2, what does that give you down below? 0, can't have it. If I plug the negative 2 in here, 0, down below, can't have it. This is a combination of both. So the numbers that will not work are 2 and negative 2. Now I need to come up with my equation, and I do that by clearing out my fractions. So here's how we clear out our fractions. We look at it as a whole, and we need to get rid of all the fractions. So we look at our denominators. So our first one here, what does it have in our denominator? Okay, so I'm going to put an x minus 2 out in front. And then what about the second one? What does it have? Okay, so I need an x plus 2 here. And now I'm going to distribute. And this is going to clear out our fractions. So let's see what happens. Okay, I'm going to cover up pieces so we can see what happens. Okay, when I'm here, so we're going to look at the first piece here. The minus 2, the x minus 2 and the x minus 2 down below, those cancel. Okay, so they're gone. So what's left over? We got a 3, right? And an x plus 2. So that's going to be that piece. Okay, because those cancel. Now we go to the next one. Okay, what happens here? The x plus 2 and the x plus 2, they do what? So what's left over? 1, yep, times x minus 2. And you can put the 1 there or not. It doesn't matter. So x minus 2 there, because the plus is canceled, right? And what happens on the right-hand side? Those completely cancel, don't they? So what's left over on the right-hand side? 12. Now we've got something that we can now solve. This is linear, and so we'll solve it quickly. Should not be difficult at all to solve. So distribute through. We have a 3x plus 6 plus x minus 2 equals 12. Combine like terms, so that is 4x plus 4 equals 12. Move your 4 over. So 4x equals now 8. We'll divide by our 4. And what do I get for my possible solution? 2. Now, is 2 going to be an answer? No. Why is 2 not going to work? Because we have to take this and check it over here. Well, 2 is not going to work. Why not? Because it is not in the domain. Okay, so we got an answer, but it doesn't work. So this one actually has what? No solution, right? Now, if this would have been a 5, it would be okay. And you would get your answer of x equals 5. No problem. But if you get a number, and maybe you get 2 of them. Maybe you get 2 answers. One of them may work. One of them may not. So you take whatever you got and then just check and make sure they don't match up with numbers over here. And we're going to do probably 3 of these. I want to make sure we know how to solve them. These, I think, are the hardest because you've got to clear out all of these fractions. And 2 doesn't work because it matches up here, right? That's why. Okay, let's try another one. And let's look now at... let's look at one that's going to require a lot of factoring. How about we look at question 26. Okay, let's look at question 26 here. They're all a little bit different. We're going to look at question 26. I do what now? Yep, same page. Page 164. So page 164, question 26 here. We've got 4x plus 3 over x plus 1 plus 2 over x equals 1 over x squared plus x. What I would do first is I would work with the right-hand side and I would try to factor this. So this here is going to factor. What can I factor out of here? Well, it looks like over here I can factor an x out. All I did was I factored that x out. Now we need to figure out and determine what numbers are not in the domain. So what numbers will not work? And 0, right? So what is not in the domain? Okay, x equals -1. Where did that come from? Yep, that gives you 0 there. And what's our other one? 0. Okay, that gives you 0 there. Now what do we need to do? We need to clear our fractions. So what do we need to multiply by? X, yep, and an x plus 1, right? Because that is going to take care of that one. We need to make sure we use the largest one. That's x plus 1 takes care of that. The x takes care of that. And this takes care of that. Now let's multiply through and see what we get. So when we multiply through, what happens on our first piece? So let's look here and see what we have. Okay, the x plus 1 and x plus 1, those do what? Cancel out. So what's left over? Okay, we've got an x out in front, right? And we've got a 4x plus 3, right? Because those cancel. And that left you with that. What about the next one? We have a 2 out in front. And what canceled? The x's. So we have a 2, and what do we multiply it by? X plus 1. And then on the right-hand side, all of it does what? Cancels, so it leaves you with a 1. This one is going to require us to factor, I believe. So we're going to distribute that x through. And the 2 through. And now we've got 4x squared plus 3x plus 2x plus 2 equals 1. And I do realize these take quite a bit of time to go through. And when I picked them out, I tried to pick out ones that didn't take a long time, because some of these get really complicated. When I picked out questions for your homework, I was very careful to give you ones that don't take a long time, because some of them require a lot more work than others. So now what are we going to do? We're going to combine these together, and that makes it a 4x squared, right? Plus 5x plus 2 equals 1. We're going to set this equal to 0 by moving that 1 over. Okay, and now we've got this. Okay, now we've got a factor. Now, unfortunately, this one we cannot just jump to our factors. So what we're going to have to do is grouping. So we take the first number times the last number. 4 times 1 is a 4. What two numbers are going to make it work here? 4 and 1. We cannot jump to our factors because of the 4 out in front. So remember, from 1, 4, what do we have to do? We have to break it up. So we break that up now into 4x squared plus 4x plus x plus 1. And we group. What can we group out of the first two pieces? 4x. Okay, so that comes out. And that leaves you with an x plus 1. The next two pieces, nothing's in common, but I can always take out a what? 1. Are my groupings identical? Yes. So now we've got, when I rewrite it, x plus 1 comes out, 4x plus 1 left over. Now we can factor it, and we're going to get two solutions, but I think one of them is not going to work and one of them will work. So we're going to get two possible solutions, but only one of them is going to check out. So x plus 1 equals 0, so x equals a -1. And the other one is 4x plus 1 equals 0. 4x equals -1, divide by our 4. So x equals a -1/4. So now let's talk about these here. Which one of these is not going to work? So we've got two solutions. Only one of them is going to work. Huh? The x minus 1 is not going to work. Why not? Okay, because this is not in the domain. And so what we're going to do is cross this one out, and the only solution that we have is now x equals minus 1/4. Now does it make sense? So we work it all out, we figure out what our possible solutions are, and then we check them with that first step that we did. And you may have two solutions, they may both not work. You may have two solutions, they may both work. Or one of them may work. But you don't have to plug them back in. All you have to do is look and see which numbers can't work and make sure they're not one of those. I don't think we have enough time to do another one of these, but we have one more type of question to look at. And these are the last part. These are the applications. So the very last part of this section, we just have a little bit more to cover. I know there's a lot of material in this section. So we're still in the same section. We're still in 1.6. We're going to now look at some applications that involve work. So these applications are going to use work. And when we look at work, and how we need to see how much is done per unit of time. So we need to make these into fractions. So I'm going to pick two of these out. We'll talk about them, and we'll solve them. And they're actually very easy once you see how to set them up. They're the easiest applications that we have. So I'm going to look at question 37. Painting a house. If Joe can paint a house in 3 hours, and Sam can paint the same house in 5 hours, how long does it take them to do it together? Well, I cannot just add them together. Because if I tried to add them together, I would get 3 plus 5, which would make 8. And it doesn't make sense because Joe by himself can paint this house in what? 3 hours. So our answer has to be less than 3. So what we look at with each of these is how much is done per hour. So each of these, we look at the amount of work that's done per hour. This is question 37, and this was on page 165. Okay, and we're going to be looking at how much work is done per hour, per unit of time. These are going to add together because they're helping each other. So we're going to look at Joe first. Now, Joe, it takes him 3 hours to paint this house. So how much is done in 1 hour? 1/3. How long does him working with his friend Sam take to paint the house? We don't know, so his time is X, right? We don't know how long it takes him working with Sam. What about Sam? Sam takes him 5 hours. So how much does Sam do in 1 hour? Okay, 1/5. Sam's time, again, we don't know, so that's our unknown X. These are working together, so they're going to add. Now, the next one will be subtraction. This one is addition because they're helping each other. So in this case, we're going to put them together. And what our equation looks like is this. Our equation looks like this. We have Joe and we have Sam. And just like we did with our distance, we multiply. So this we put together. For Joe, we're going to use 1/3 X because those go together. Sam is going to help him, so that's 1/5 X. And it's going to equal 1. Why is it going to equal 1? It equals 1 because we paint one house. So we're going to paint one house. That's why it equals 1. It always equals 1. Because you're always painting one house or filling one pool or cleaning one yard. So it's always going to be 1 because that's one house or 100% of the job done. So it equals 1. Now, how do we finish this out? How do we get our actual solution? We clear our fractions. So what do we need to multiply everything by? If I gave you this and I said solve it, what would you multiply everything by? 15. Why 15? Yep, because 15 is the least common denominator of 3 and 5. So that's our 15. Now we distribute through. So this is linear. So we can directly solve it. So 15 divided by 3, 5x. Okay, bring the x down with it. 15 divided by 5 is a 3x. And 15 times 1 makes it a 15. Add those together, and we get an 8x equals now 15. We divide by our 8, and x now equals 15 over 8. And that's going to be your answer, and that's going to be in terms of hours. And you could break that down into minutes if you wanted to. You don't really need to. Let's see if it makes sense. Why does this make sense? Okay, what is 15 divided by 8 in our calculator? That's 1.875, right? Now, what do we know about our answer? Our answer has to be less than 3. Why less than 3? Because Joe can paint the house by himself in 3 hours. And if he has a helper, it's got to be less. And that's definitely less than 3. So we know that we did it correctly. And you could make this into minutes if you wanted to, or you could just leave it as a fraction there. Now this is one where they added together. The last question that we're going to look at, and I'll go ahead and pass out the sign-in sheet. The last question that we're going to look at is one where they subtract from each other. And in this one, we're going to be filling and draining a swimming pool. So this is question 41. An inlet pipe can fill Blake's pool in 5 hours. An outlet pipe can empty it in 8. In his haste to surf the internet, Blake left both pipes open. How long did it take him to fill the swimming pool? Okay, so let's think about what we've got. We've got water coming in, and we've got water going out. So we've got water coming in, filling up a swimming pool, and we've got water going out. So we're going to fill it, and that's positive, and we're going to drain it, and that's negative. So let's think about what we have here when we read it. An inlet pipe can fill this pool in 5 hours. So how much is done in 1 hour? Okay, we use that 1/5 again, and time is unknown, so that's x. We also drain water out. So when we drain water out, it's negative. And how fast is this drain? Or how long does it take to drain? To drain this pool, it takes it 8 hours. How much is done in 1 hour? How much of the pool is drained out? 1/8. And we don't know the total time working together, so we use an x with that. Now, why are these going to be subtracting? because one is filling, one is what? Draining. We put them together, and so we have 1/5 x minus 1/8 x, and that equals 1. Why 1? Because you're filling up what? You're filling up one pool. And it is always going to equal what? 1 every single time. How would I now clear out my fractions? 40. Why 40? Because that's the least common denominator of 5 and 8. That's your 40. So distribute through. 40 divided by 5 is an 8x. 40 divided by 8, that leaves you with a 5x. And 40 times 1, that's a 40. Now we've got, putting them together, 3x equals 40. Divide by your 3. And x now equals 40 over 3 hours. And you could break this down if you wanted to. Now, why does this make sense? Okay, let's see what that 40 over 3 is as a decimal. Okay, 40 over 3 as a decimal is 1.3 repeating, right? So that's 13 1/3 hours. Now, why does that make sense? Well, how long does it take to fill up that swimming pool? 5 hours. Okay, we are also draining at the same time, so that means my time has to go what? Up, right? So it has to be more than 5 hours, and it is. 13 1/3 is definitely more than 5 hours. So we know we did it correctly. So what's our homework for next time? Our homework for next time is at 1.6. So you should be able to finish that packet for Tuesday. And if you have a lot of questions, that's fine.